Good morning. So today we're going to discuss chapter 10. So we'll start in this particular video, we'll start with example 10.1. So in example 10.1, we're going to use the extent of the reaction to find uh, the number of moles or the percentages of chemical species in the product, no? So let's go. Let me share you the PowerPoint. Okay, so this is chapter 10 of Himmelblau. Chapter 10 is about material balances for processes involving reaction. And then as you can see, this is a little bit more complicated than our topic in the prelims. Kasi nung sa prelims tayo, wala pang chemical reaction. So, nung prelims kasi usually to equation to unknowns lang, ano? For processes involving chemical reaction, generally, you're going to use stoichiometric ratios, no? To solve the problem and the balanced chemical reaction. Okay. So this is the extent of the reaction definition. You already encountered this in chapter 9 of Himmelblau. And then the extent of the reaction is generally equal to N sub I out. That is the number of moles of a chemical species is still present after the reaction has occurred. Okay. This is the final number of moles of a chemical species minus N sub I in. So N sub I in, this is the initial number of moles of a chemical species. Kumbaga, this is the number of moles in the feed. And then B sub I right here is the stoichiometric coefficient in the chemical reaction. So ang convention natin sa stoichiometric coefficient is pag reactant negative, pag product positive. Just remember that. Ano? Okay. And then this is a very important of the extent of the reaction. You need to remember this property of the extent of the reaction so that you will be able to use the concept of the extent of the reaction in solving problem that asks you to predict the number of moles still remaining in the product after a reaction has occurred. So you need to remember that the extent of the reaction is constant for a specific reaction for any species, whether it is a reactant or product. When a given that the initial number of moles and the final number of moles of a specific reactant or product. Pag meron kayong given the initial number of, one species, yung reactant, given yung initial number of moles niya, tapos yung final number of moles niya, yung extent of the reaction for a particular reaction is constant. Kahit alin pa yung kunin yung kahit ano pang i-consider nyo na reactant or product. No? So, let me illustrate this property of extent of the reaction. Let's have an example. Let's consider this reaction. Nitrogen gas, 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas to produce 2 moles of ammonia. So suppose 1 mole of nitrogen gas react with 3 moles of hydrogen gas to produce 2 moles of ammonia. Okay, and then let's try to calculate the extent of the reaction for nitrogen, hydrogen, and ammonia. So you need to expect that the extent of the reaction for the three chemical species should be equal. So basically, pag nakuha nyo na yung extent of the reaction sa isang chemical species, you can use that extent of the reaction to calculate the number of moles in the product of the other species. Ganun yung basically yung technique. Let's try to illustrate that in this particular example. The extent of the reaction for nitrogen, di ba, the equation is N out minus N in divided by the stoichiometric coefficient. So for nitrogen, N out, complete yung ating reaction. So walang matitirang nitrogen. So that would be 0. Tapos minus N initial, we have 1 mole of nitrogen. So minus 1 divided by yung stoichiometric coefficient ng nitrogen sa reaction ay negative 1. Negative kasi reactant siya. So ang extent ng reaction sa nitrogen ay 1. Let's try to do that for hydrogen. So for hydrogen naman, lahat din ng hydrogen nag-react. Initially you have 3 moles tapos naubos kasi complete yung reaction. So 0 yung ano niya, yung final number of moles ng hydrogen. Tapos minus yung initial niya, 3, we have 3 moles of hydrogen. So minus 3 divided by negative 3. Kasi reactant yung hydrogen, so negative 3 yung kanyang stoichiometric coefficient. So pag sinolve nyo to, you're also going to get 1. So as you can see, the extent of the reaction for nitrogen is 1. The extent of the reaction for hydrogen is also 1. Okay, let's try to solve the extent of the reaction for ammonia. For ammonia, initially, we're going to assume that there's no ammonia kasi wala namang information dun sa example. So initially, ammonia has 0 number of moles. Tapos, yung number ng moles, final number of moles ng ammonia ay 2. Ito, 2. So 2 minus 0. Tapos yung stoichiometric coefficient ng ammonia kasi product siya ay positive 2. Pag product positive, pag reactant negative. So 2 minus 0 divided by 2 is also equal to 1. So, yan. Basically, equal lamang yung, sa isang reaction, equal lang yung extent of the reaction. Basta meron kayong given na initial number of moles ng one species at saka yung final number of moles ng isang species. So as you can see, pag alam nyo na, halimbawa, alam nyo na extent of the reaction, and then you wanted to calculate the number of moles of H2, you can use this, the extent of the reaction of nitrogen on hydrogen, and then you can calculate the final number of moles of hydrogen and also of ammonia. Basically, ganun yung technique. Okay? And then just try to remember that the stoichiometric coefficient in convention is negative for reactant and positive for product. Okay. So another important concept is the maximum extent of the reaction, or Emax. So Emax is calculated. First, let's discuss how Emax is calculated. Emax is calculated by assuming that all reactant is consumed or reacted. So ang may Emax lang, yung reactant lang. Siyempre walang Emax yung products, yung mga reactants lang. So Emax is calculated by assuming that all reactant is consumed or reacted. Anong consequence nito? Pag in-assume natin na lahat ng reactant ay na-consume, yung final number of mole ng reactant ay palaging 0. No? So, ang kailangan nyo lang malaman in calculating Emax is the initial number of moles ng reactant. Okay? So ano bang gamit ito? Why do we need to calculate Emax? So generally, Emax is calculated to determine the limiting reactant. Paano ba yun? Siyempre, yung the raw material or reactant with lower Emax is the limiting reactant. Kasi generally, mas konti yung limiting reactant, so yung Emax niya mas mababa, no? So that's the practical importance of calculating Emax. Calculate the, halimbawa, dalawa yung reactant nyo, calculate the Emax of reactant 1, calculate the Emax of reactant 2, and then the one with lower Emax is the limiting reactant. Okay, so let's try to solve example 10.1. Karen, pasaksak nga nito. Karen. Parang nakasaksak mo. Parang sige lang, inaayos ko lang. Okay, so let me read the example 10.1. Reaction in which the fraction conversion is specified. Ibig sabihin, given yung no conversion. Okay, let's first read the problem. The chlorination of methane occurs by the following reaction. So CH4 plus Cl2 will give you CH3Cl plus HCl. You're supposed to be familiar with this reaction kung nag-organic chem na kayo. Ano? You are asked to determine the product composition if the conversion of the limiting reactant is the 67%. And the feed composition in mole percent is given as 40% CH4, 50% Cl2, and 10% N2. Okay. So basically what we're going to do is, first, we're going to determine which is the limiting reactant, no? By calculating Emax. Tapos, after calculation of the, limiting reactant, after knowing the limiting reactant, we're going to calculate, the extent of the reaction. Kasi, in order to calculate the extent of the reaction, you should be able to calculate the final number of moles of the limiting reactant. No? So we're going to use the conversion, yung 67% conversion, to determine the total the number of moles, the final number of moles of the limiting reactant. And then if you have the final number of moles of the limiting reactant, you can now calculate the extent of the reaction. Tapos after calculating the extent of the reaction, you can use the extent of the reaction to calculate the number of moles of the reactant and species after the reaction. Basically, yun lang. Now, so let's start by calculating Emax. There are two chemical species. So now there are two reactants, methane and chlorine. So let's calculate first the Emax for methane. Okay. So if you still remember the formula, Emax is still equal to N sub I minus N sub IO divided by B sub I. Pero in the case of Emax, yung N sub I ng methane is automatically will become 0. No? And then yung B sub I ng methane is negative 1 kasi siya, reactant siya. Ito yun, no? Diba? It's negative 1. Tapos N sub IO. We need to find N sub IO. So in order to find N sub IO, ang gagawin natin, we're going to assume or we're going to use a basis na we have 100 moles, no, of initial material of feed. So ang consequence nito, meron tayong 40 moles ng CH4. Okay? So this would be our this would be our N sub IO. So minus 40. Okay? So as you can see, Emax for CH4 is approximately equal to or exactly equal to 40. Okay. Let's try to calculate Emax of Cl2. So the same equation, ano? N sub I minus N sub IO divided by B sub I. So that would be 0. Palaging 0 pag Emax, ano? And then for chlorine, the initial number of moles is 50. Ito, ano? 50. So minus 50. And then negative 1 kasi reactant siya. So yun, ano? So the Emax for chlorine or Cl2 is 50. Okay? So from this 2 Emax, we can say that CH4 is the limiting reactant kasi mas mababa yung Emax niya, ano? So therefore, CH4 is the limiting reactant. Okay, so upon knowing that CH4 is the limiting reactant, we can now calculate the final number, the actual number of moles of CH4 in the product. So, pag merong conversion, ang formula lang niyan is yung final number of mole, N sub I, is equals to N sub IO times 1 minus X. Ito yung X is the conversion. Ano? So, try to remember this equation pag merong conversion. X is conversion. Conversion fraction. Not percentage. Kasi, ang ginamit ko kasi ito, 1. Ano? Kung ginamit nyo 100, so gamitin nyo yung percentage. Okay? So, halimbawa, initially you have 40. Tapos, 1 minus 0.67. So, the number of moles of CH4 in the product is 13.2. Okay? So, ganun lang. Ano? And then, the next step is we need to calculate the actual extent of the reaction. So, and then we're going to use that to calculate the number of moles of Cl2, the number of moles of CH3Cl, and the number of moles of HCl. Okay? So, may space pa dito. Ano? Calculate natin yung actual E. Ito yung actual E. Iba to doon sa Amax. Ano? Kasi hindi naman, as you can see, hindi naman talaga naubos yung CH4. 67% lang yung conversion. Ito kasi yung Emax na 40 na yan, naubos yung CH4. So ito yung actual E. So actual E, ganun pa rin yung formula natin ng ng extent of the reaction. N sub I minus N sub IO divided by B sub I. So na-calculate natin yung final number ng ng moles ng methane, 13.2 minus yung initial niya 40. Tapos, divided by negative 1. Kasi reactant siya. Ano? So, ang extent of the reaction ay (26.8). Okay. So, gagamitin natin itong 26.8 to calculate the number of moles of Cl2 in the product, the number of moles of CH3Cl in the product, and the number of moles of HCl in the product. So, tandaan lang natin yung 26.8. Ano? Yung magic number. Ito yung magic number natin. Yung CH4 natin, ito gagamitin din natin ito mamaya. Kasi ang tinatanong dito is the percentage composition. We have 13.2 mole of CH4. Okay, I'm going to clear the board. Okay, let's try to calculate Cl2. So basically, in order to calculate Cl2, ang gagamitin natin yung ECl2. This is just the same as ECH4. Ano? ECl2 at saka ECH4 equal lang yon. Kasi isang reaction lang naman sila. And then, ito pa rin yung equation natin. N sub I minus N sub IO divided by B sub I. So notice na in the case of Cl2, alam natin ito, no? Ito alam din natin, this is 50. Tapos yung B sub I negative 1. Ang makakalculate natin dito, yung number of moles ng Cl2 sa product. Ganun lamang yun. Ano? So, 26.8 ang E, ang extent of the reaction. Calculate natin yung final number of mole ng Cl2. Ang initial natin ay 50. Tapos divide natin ng negative 1. So, as you can see, you'll be able to get NCl2 is equal to 23.2. Okay, that's correct. Okay. Tapos let's try to calculate number of moles of CH3Cl. So the same technique, yung ECH3Cl parehas lamang yan ng ECH4. Tapos yung definition na yung formula natin for extent of the reaction na N sub I minus N sub IO divided by B sub IO, B sub I, yung pa rin yung equation ng extent of the reaction. So, still, ang extent of the reaction for CH3Cl ay 26.8 pa rin. Tapos yung number of moles of CH3Cl, hinahanap natin. Initially, wala namang in-state sa problem na may CH3Cl. So, ang initial nito ay 0. Tapos, divided by, ang B sub I ng CH3Cl ay 1, positive 1, kasi product siya. So, as you can see from the reaction, you can conclude that the number of moles of CH3Cl in the product is 26.8. In the case of HCl, ito. Ganun din yung solution, no? So, HCl is just 26.8 kasi equal din siya sa ECH4. And then, we're going to use the same equation, N sub I minus N sub IO divided by B sub I. And actually, if we're going to substitute everything in this equation, you're going to end up with the same answer. Ano? Kasi 26.8 is equals to N sub I. Ito yung magiging NHCl. Tapos N sub IO, wala ring HCl initially, nakalagay sa problem. Tapos B sub I is also positive 1 kasi product siya. And then as you can see, NHCl is also 26.8. Okay. So yun, na-calculate na natin yung number of moles sa product ng bawat chemical species. Ang tinatanong ng problem ay product composition, no? So pag sinabing product composition, percentages yan ng bawat chemical species. Okay? So yung nitrogen, itong nitrogen, hindi siya nag-react, no? So kung ilan yung pumasok sa feed, yung pa rin yung number of moles sa product. So ibig sabihin yan, therefore, the number of nitrogen is 10. 10 moles. Ano? HCl, 20, ito moles din to. Ito moles din to. Ano? Lahat yan moles. Pati yun. Okay. So try to add all the number of moles of each chemical species, no? So 26.8 this one plus 26.8 of HCl plus 10 mole of H2 plus 23.2 moles of Cl2 plus ilan yung natirang methane. Yung methane natin is 13.2. So try to add all of those, no? And then you'll be able to find out, no? Yun yung calculator nyo. And then makukuha nyo yung total number of moles ay equal sa 100. So anong consequence doon? Pag 100 yung total number of moles. So ang consequence doon, kung ilan yung number of moles, yun na rin yung percentage, di ba? Ganun lang yun. So for example, ang Cl2 ay 23.2% sa product. Okay? Yun yung consequence nun. Ang CH3Cl, 26.8% sa product. Ang HCl, 26.8% sa product. Ang nitrogen, 10%. No? Tapos ang methane ay 13.2%. Okay? So I hope you understand this problem, and I hope you can apply the technique in solving other problems. Okay? Basically, kita nyo, no? First, you need to determine the limiting reactant by calculating Emax of the reactant. Ano? Second, calculate the extent of the reaction, the actual extent of the reaction. And then use that value to calculate the number of moles of each species. And then basically you're done. Ganun lang, ano? So I'm going to pose an exercise. I hope you try to solve that exercise, ano? Para ma-practice mo. Okay? So try to solve the exercise. Probably ang midterm natin, we'll try to finish chapter 10 and then we'll have our midterm probably next week, you know. Kaya lang medyo mas complicated kasi yung mga dito yung solution. Hindi siya pwedeng hindi kamukha nung prelims natin na pwedeng medyo limited kasi yung blackboard. Kumbaga, pag medyo mahaba na yung solution, hindi na siya kaya ng blackboard na na magbigay ng different events. Even. So, we'll have a specific date and time for your midterm, unlike nasa prelims. So, ang gagawin ko na lang is, halimbawa, you're not available for whatever reason on that particular schedule, we'll have another schedule, before the term ends, para makatake kayo ng kung hindi kayo makaka-attend sa regular schedule. So today is Saturday, and then probably next week matatapos natin yung chapter 10. So probably by June 22, that's a Monday, we'll have our midterm. Doon siguro sabihin ko na, i-announce ko na lang kung ano yung specific time ng midterm natin. Okay, so just watch out for the next video. We'll try to solve more problems in this chapter. So bye-bye for now.